Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have got an isometric 3D projection of a solid in which the three faces, that is the front face, top face and the side face of the solid, they have been represented into a single 3D projection, and using the information available through this isometric projection we are required to draw the orthographic projections of the solid, that is front view, top view and the right hand side view projections of the solid needs to be evaluated. Now first of all we have to start with the evaluation of the dimensions regarding the front view face, top view face and the side view face. Now looking at the solid from the front, so we have got the width of the solid equal to 60 millimeter, height of the solid, this is equal to 55 millimeter. So the dimensions of the front view face will be 60 millimeter by 55 millimeter. Now when we look at the solid from above, that is the top view dimensions will be width, it is equal to 60 millimeter and the depth of the solid happens to be 55 millimeter. So the dimensions of the top view face will be again 60 millimeter by 55 millimeter. Now when we look at the solid from the side view, then we are going to have the depth of the solid, it is equal to 55 millimeter and the height of the solid, it is also equal to 55 millimeter. So the side view face, it will be a square having edge equal to 55 millimeter. Now let us work out what are the different surfaces which will be visible to us when we are going to look at the solid from the front side, from the top side and from the right hand side over there. So whenever we are going to look at the solid in the front view, that is from the front side, so we are going to see that there are four surfaces which will be visible to us, and we can observe over here that all these four surfaces, surface A, surface B, surface C and surface D. So all these four surfaces, they happen to be parallel to the vertical plane, and the true shapes of all these four surfaces, they will be obtained onto the vertical plane in the front view projections over there. Now when we look at the solid from the top view, so we can check over there that there are three surfaces. This is surface 1, this is surface 2, then we have the surface 3. So these three surfaces will be observed onto the horizontal plane in the top view, and since all of these three surfaces, that is surface 1, 2 and 3, they happen to be parallel to the horizontal plane, so the true shapes of the surfaces 1, 2 and 3 will be observed onto the horizontal plane in the top view. Next, when we look at the solid from the right hand side, so we observe that there are three surfaces, X, surface Y and surface Z over here. So this is surface X, Y and Z. This is X, this is a square surface, surface Y, and again you have surface number 3, right? So these are three surfaces which are visible to us, and now since once again three surfaces X, Y and Z, they happen to be parallel to the profile plane, so therefore the projections of these three surfaces X, Y and Z as obtained on the profile plane will provide us with the true shape of these three surfaces, right? So let us start with the construction of the orthographic projections corresponding to the solid. So we have to draw the XY reference line, then the X1, Y1 reference line needs to be drawn. Now since the right side view of this object needs to be drawn, so the right side view in the first angle projection will be drawn on the left hand side. So over here we are going to obtain the front view above the XY line. Over here below the XY line we are going to obtain the top view of the solid, and over here the right side view of the solid will be obtained. Now these are the surfaces in the front view, top view and the side view. Now let us start with construction of the front view of this particular solid. Now we know that corresponding to the front view, we are looking from this side in order to obtain the front view of the solid. So the width of the solid happens to be 60 millimeter and the height of the solid happens to be 55 millimeter. So we have drawn this width equal to 60 millimeter. So two projection lines, they have been drawn. So they are separated by a distance of 60 millimeter. Similarly, the height of the front face of the solid will be 55 millimeter. So front view face we have obtained as a rectangle having dimension 60 millimeter by 55 millimeter. So this is 60 millimeter and this is 55 millimeter. Now this top projection has been extended onto the right side view because in the right side view the height of the solid will be required. Similarly, the width component which was obtained in the front view, it has been projected onto the top view projections as well, since we are going to require the width dimension even in the top view. Now we have got the rectangular face corresponding to the front view. Now let us complete the rectangular face corresponding to the top view. So this is our top view in which the width is equal to 60 millimeters. So this width was already dimensioned in the front view. So we are not going to repeat the dimension over here again. Now the depth we have mentioned over here. So the depth of this solid, it is equal to 55 millimeter. So this is the top view face of this particular solid, which again measures 60 millimeter width and 55 millimeter is the depth of the solid. Now the dimensions which were obtained on the top view, that is regarding the depth, so they could be transferred onto the right hand side view by using this transfer line. So this is a transfer line which has been drawn at an angle of 45 degree, and then using this transfer line, so all the dimensions related to the depth, they can be transferred onto the right hand side view. So in the right hand side view, so this is the depth which has been transferred onto the right hand side view. So this depth is equal to 55 millimeter. So this is 55 millimeter. So here we have depth is equal to 55 millimeter and the height, it is again coming from the front side view, it is equal to 55. So these dimensions we have deliberately added just to improve the understanding. But later on we are going to remove these dimensions because by adding these dimensions over here, it is going to lead to repeatability of the dimension, because 55 we are already mentioned in the front view and this depth of 55 it was mentioned in the top view. But later on we are going to remove this. Right now we have obtained the faces, that is the front view face, top view face and the side view face over there. So this complete information has already been drawn over here. Right now let us start with the construction of the front view orthographic projections for the solid. So let us observe the solid from the front. So we work out that there is a lower web, or we can call it even as a bottom block. We call it a lower web or a bottom block. So corresponding to this bottom block, we have got a height is equal to 15 millimeter. So the height of this bottom block happens to be 15 millimeter. So here we have marked the height of bottom block as 15 millimeter. So this is corresponding to the surfaces A, B and C. That is the surfaces A, B and C, they are having height equal to 15 millimeter. And then another thing, the width of surface A happens to be 15 millimeter. The width of surface C happens to be 15. So the width of surface B will be 30 millimeter. Similarly, we have got the second step over here. Now in this element, that is the surface D, if we look at, so upon this surface D we find that there are two cross sections. That is, on the top of surface D we have got surface 2 located at the topmost portion, and then surface 3 is located at a depth of, you see, with a height of 20 millimeter, which is moving down. So this way, this height was 15 and then this height is 20 millimeter, because this total height happens to be 35 millimeter. So total height corresponding to surface 3 is 35. So we have marked another 20 millimeter from the top of the surface 1. So surface 1 we had obtained while we had marked this height of 15 millimeter corresponding to surface A, B and C. Now surface 3 height, this is equal to 35 millimeter. So 15 millimeter we had already marked. So 20 millimeter we have added on to that. So this distance becomes 35 millimeter from the base, right? Now we have got the vertical dimensions as well, because over here we find that the width of surface A happens to be 15 millimeter. So we have marked this width of surface A equal to 15 millimeter. So please check, this is the width of the surface A, and we have not projected it upwards because we are only talking about this lower block or the lower web. So this height is equal to 15 millimeter and the width is also equal to 15 millimeter. So surface A in the front view has been obtained once we have drawn this vertical projection line. Similarly, on the other side, if we are going to look at this particular surface from the right hand side, right? This is the right hand corner over there of this block. So looking at the solid from the right corner, so again we find that if we move towards the left corner by a distance of 15 millimeter, so 15 millimeter, it is the distance or the width of our surface number 3. So once we have drawn this vertical projection line, so surface C has been automatically located. So once we are located surface A, and this remainder portion we can check, this is our 30 millimeter width and 15 millimeter height. So this is our representation of surface B. So surface A, surface B, this one, and surface C, all these 3 surfaces they have been located. Now let us work out surface D. So surface D will be located because you can check this surface over here, surface 2 and surface 3. The width of surface 2 happens to be 30 millimeter, and similarly the width of surface 3 happens to be 30 millimeter once again. So please check, the width of surface 2 happens to be 30 millimeter and the remainder is width of surface 3. So this is also 30 because the total width happens to be 60 millimeter. Now we can complete the darkening of the edges because all the surfaces they have been obtained. You can check, this is my surface number D over here, right? So this is my surface number D, right? So A has been located, B has been located, C has been located, and now this is my surface D. So all the 4 surfaces of the front view they have been located. So left side edge, it is visible, so we have drawn it dark. Then you move 30 millimeter, this is my surface 2, right? This is my surface 2, the width is equal to 30. And once you reach this corner, you have to move down by 20 millimeter. That is, you have to descend by 20 millimeter over here. So you move down by 20 and again you move towards right. This is my surface C. So from this point, I have to move down to this point, right? And then you move down by 35 millimeter. So this is my total dimension, vertical edge, 35 millimeter. Then I'll be darkening this edge and this edge over here. Now I have obtained all the 4 surfaces of the front view, and since all these 4 surfaces, surface A over here, surface B corresponding to this surface, surface C corresponding to this square surface over here, and then this is my surface D. And since all these 4 surfaces they happen to be parallel to the vertical plane, so the projections of these 4 surfaces as they are obtained on the vertical plane in the front view, they are representing the true shape of these surfaces. So the front view has been completed. Now let us start with the top view projections. In order to draw the top view projection, 2 things will be required. So please check, from the rear surface, this is my rear surface, this is my rear surface over there. So from this rear surface, I have got 2 surfaces, surface 2 and surface 3, which are at a distance of 20 millimeter. That is, the depth is there 20 millimeter from the rear surface. So I can mark this depth equal to 20 millimeter from the rear surface, and I can draw a projection line. And the moment I draw this projection line, please check, this is the surface 2 which has been obtained, and it is a true shape of the surface 2. And then this is my true shape of the surface 3. So two surfaces have been obtained over here. Now I need to obtain this part. Okay, so this part needs to be obtained. So once again, I know that this depth is also equal to 15 millimeter. So this depth, this is also equal to 15 millimeter. So once I know this depth equal to 15 millimeter, then I have drawn a projection line at a distance of 15 millimeter depth from the front face. This is my front face. So from the front face, there is a depth of 15 millimeter towards the back side. And once I draw this, now my surface 1 is also identified. That is, please check, this is my surface Y. I move along this, come this way, go back, again, come this way, and this will be completing my surface 1 projections over there. So let me darken different surfaces. So this is the surface 2, this is my surface 3, and here once I draw this one, this is my surface number 1 over here. So surface 1, surface 2 and surface 3. All these three surfaces, they happen to be parallel to the horizontal plane. And since these three surfaces, they happen to be parallel to horizontal plane, so the projections of these three surfaces, surface 1, surface 2 and surface 3, as they are obtained onto the horizontal plane in the top view, they represent the true shape of these three surfaces. Now we move on to the right hand side view. So now all the, you see, dimensions, they have been marked. Only thing is I have to do the darkening. So please check, this is my surface X. So surface X I will be able to obtain this way. I am moving like this over here, and then I move along this portion. So this is my surface X, and then this portion will give me my surface Y over here. This is my surface Y. And regarding surface Z, so surface Z has been overlapped by surface X, but still it is a different surface. So here the dotted line will be drawn, and this will represent my surface Z. Okay, so let me complete it. So here I have got surface X, this is the complete portion, surface X, this is my surface Y, and this is my surface Z. And over here, since surface Z, it was overlapped by surface X, so corresponding to this edge over here, I have to draw a dotted line. So this is the complete construction of the right hand side view which has been obtained on the left hand side. So with this, we have completed the construction of the front view, top view and the right hand side view orthographic projections of the solid. Now we can remove these markings of the faces so that we can have a clear picture of the solid, as well as we should have the clear picture of the orthographic projection, so that the better understanding can be obtained regarding the interrelationship between the isometric projections and the orthographic projections of this particular solid. So this is all for today. So we are going to continue with the discussion regarding the construction of the orthographic projections for few more solids over there in the coming lectures. So thank you very much. Thanks a lot.